Hello, grade 12 students. This is our third lecture regarding our lesson, which is logarithmic function. So let us remember together what did we learn so far. So first of all, we defined what's a logarithmic function. We learned some properties about len. We also learned how do we do the derivative of a len. Also, we solved exercises about limits and how do we draw the graph of a logarithmic function. And now I'm going to solve a complete exercise where you are going to study the whole variation of a logarithmic function, starting from the domain to the drawing of the function. So first of all, I'm going to take our example, which is len x, f of x equals len x. F is defined continuous over the domain 0 to plus infinity. So as we do in all our functions, we're going to do the limits, the derivative, study variation, table of variation, and then the graph. So the limit of the function when x tends to 0 plus, you know that len 0 plus is minus infinity. So the straight line of equation x equals to 0 is a vertical asymptote to c. Limit of the function when x tends to plus infinity is len of plus infinity, which is plus infinity. Now the derivative. What's the derivative of len x is 1 over x, and this function is positive for every x, then f is strictly increasing. So this is the table of variation of the function, where we put the domain at the top, which is 0 plus infinity. We shaded the 0 because it's a vertical asymptote, and it's a positive function, then f of x is increasing. Limit for x tends to 0 plus is minus infinity, and limit when x tends to plus infinity plus infinity. We still have the drawing of the function, and now we're going to draw the graph of the function. So I'm going to take particular points. The particular points are going to be len 1, which is 0, and len e, which is 1. So len 1, 0 is this is the first point. Len e is 1, e is 2.7 something, so this is e, and this is okay. And you know that x equals to 0, which is the vertical asymptote, is an asymptote to the curve, so it's the y prime o x, the y prime o y. So now we're going to join the points. This is the asymptote. Let me just make it clearer. I'll try to draw with the highlighter. Maybe it's better because it's going to be more straight. This is the function, and it's increasing, so in this way. So this is the graph of the function somehow. And now we're going to have another exercise. We have the function f of x equals 1 over x into 1 minus len x. Its domain is 0 e union e plus infinity. Okay? And the first exercise, or in the first part, we're going to determine the limit at the open boundary. So how many limits we are going to do? 4 limits. When x tends to 0 plus, when x tends to e minus, when x tends to e plus, and when x tends to plus infinity. I'm going to start with the limit when x tends to 0 plus. So we replace x by 0, 1 over 0 into 1 plus, len 0 plus is minus infinity, and we have minus, so it becomes 0 plus infinity. I'm talking here, okay? So 0 times plus infinity, this is an indeterminate case, okay? So this is an indeterminate case. So what do I do in this case? So this is an indeterminate case. As you can see here, we have to do expand, okay? So we're going to expand and see what will happen. So it becomes x minus x len x. When x tends to 0 plus, this is 0. X len x, it's 0. So 0 minus 0, it's 0. One number over 0, it's plus infinity. Now when x tends to e minus, we have here e minus, len e is 1. 1 minus 1 is 0. Number over 0 plus is plus infinity. And now when x tends to e plus, also we will get minus infinity in this case. We still have one limit, which is the limit when x tends to plus infinity. Here we have plus infinity times minus infinity, it's minus infinity. So number over minus infinity is 0 minus. So we are done from the limits, and now we need to deduce the asymptotes. How many asymptotes here we have? When x tends to 0, we got plus infinity, so x equal to 0 VA. When x tends to e, we got plus infinity, so x equals to e VA. And when x tends to plus infinity, we got 0. So y equal to 0, also a horizontal asymptote. So here we have 3 asymptotes. After finding the limits and the asymptotes, we need to do the derivative, to study the sign, to draw the table of variation, and then to trace the curve. So to find the derivative, we have f of x equals 1 over x into 1 minus ln x. I'm going to expand the denominator, so I get 1 over x minus x ln x. So this is u over v. U is 1 and v is x minus x ln x. U is 1, so u prime is 0. V is x minus x ln x. I'm going to do the derivative of each one alone, x alone, and x ln x alone. The derivative of x is 1, and the derivative of x ln x, this is u dot v itself. Okay, so I have here another u and another v. U equals x and v equals ln x. U prime v means 1 times ln x is ln x, plus v prime u, the derivative of ln x is 1 over x times x. So after expanding, we will get minus ln x. So v prime is minus ln x. So here we are going to do u prime v minus v prime u over v squared. So we will get 0 times v minus v prime u, which is 1 into minus ln x. So the final answer of the derivative is ln x over x minus ln x, all of it squared. This is the derivative. So now I need to study sign. To study the sign, we know that the denominator is positive for every x. So we're going to take the numerator equal to 0. So the derivative equal to 0 means the numerator equals to 0. Ln x equals to 0. When does ln x equals to 0? When x equals 1. Don't forget that every time you need to discuss the sign, you have to take a condition. So ln x at the top is positive, then x should be greater than 1. Also the denominator. Okay, so here we have x equals to 1. To study the sign of 1, so this is a root, we do the table of variation now. Okay, so to the table of variation, first we need to put the domain, which is 0 e plus infinity. So e is shaded and 0 is shaded. We got only one root, which is 1, so this is the root. Minus plus, of course, because a is positive, so minus plus, because we have at the top ln x. Okay, so it's positive, minus plus, so decreasing, increasing, and this is plus, increasing. You replace the limits. So for x equals to 0 plus, we got plus infinity. For e minus, we got plus infinity. For e plus, we got minus infinity, and for plus infinity, we got 0. So this is the table of variation. After doing the table of variation, we need to draw the curve. We start by the asymptotes. I'm going to highlight for you the asymptotes. This is x equals to e, the first asymptote. This is, sorry, let me erase it to make it clear. Okay, this is the first asymptote, sorry, and this is the second asymptote, and this is the third asymptote. This is x equals to e, this is x equals to 0, and this is y equals to 0. Okay, and now we have the most important point, which is 1 1. This is 1 1, this is 1 1, increasing, decreasing from plus infinity to 1 1, then increasing. Also we have increasing from minus infinity to 0. Okay, so I wish that you have the ability now to study the variation of any function in the ln function, where you are going to do the limits, the derivative, study sign, table of variation, and then you are going to draw the curve of ln. So of course I will send you a lot of exercises to practice on logarithmic function, but before you start, you have to go for all the rules and all the properties of length, starting from equations, inequalities, limits, derivatives, and then you can start by studying their variation.